Hi and Assalamualaikum. We are from Group Techieg and today we will present our projects. So first, this is my group team members, Era Nazira, Nur Izzati Saidi, Nazifa Amir Shazwani and Nur Safiza. Our project is a well-checked smart health monitoring management system, a comprehensive healthcare solution designed to enhance patient care through a real-time health monitoring and improve communication among patient, doctor, pharmacist and administrator. The system integrates various functionalities to support and monitor the management of the health parameter, medical prescription and patient data. So for the first part, we will explain the DevOps implementation. This is the DevOps pipeline and tools that we are using for our system DevOps. Our DevOps pipeline covers the full software lifecycle using Jira for the task project management, GitHub for the code version control, Jenkins for the automate builds and tests, Docker for the containerize the apps for consistent environment, Kubernetes to deploy and manage the container in production. This pipeline speed up development, improve code quality and ensures smooth deployments. Next, we will show the configuration and setup of each tool in detail. For the GitHub setup, first, we have to create a new repository for our project on GitHub and we name the repository and set it up. After that, we add our team members as collaborators so everyone has access to the code. Next, in the Visual Studio Code, we initialize the repository in our project folder to have a Git and commit the initial code into the local repository and then publish it to the GitHub as a remote repository. From now on, any new commit will be pushed to the remote GitHub repository, keeping the code synced for the whole team.
Now, to install Jenkins, if you are a first timer, you need to go to the official website and download it for your OS. After you have installed it, run the server at the localhost 8080, then unlock Jenkins using the initial admin password, which you will find at the file path. Now you will need to start your Jenkins. So to do that, open command prompt and then navigate to the folder where you put your jenkins.war file and then run the command java-jar jenkins.war. This will start Jenkins on the localhost 8080. Then use the initial password to sign in and then you have to register your admin account. Okay, once you have registered, you can view your account by going to the dashboard, manage Jenkins and Jenkins own user database. Now to open Jenkins again later, just run the same command in cmd and go to the localhost 8080, then log in using your saved credentials. Now that you have installed Jenkins and you are able to log in, you will need to create a new item. So go to Jenkins dashboards and click on the new item. Then you will need to enter your project name, like for example, Techieg, and then select pipeline and click OK to proceed. Now to configure your pipeline, select the pipeline script from SCM and SCM to Git, and then paste your GitHub repository URL from your GitHub repo. Make sure that the branch is set to main or master, depending on your preferences. And if it's a private repo, make sure that you log in using your GitHub credential. Then just click save and apply. After that, in your project folder, you will need to create a file called Jenkins file. So this file, it will be important to you because it tells Jenkins exactly how to build and how it should be tested and deployed for your project. It kind of acts like a blueprint for your CI or CD pipeline. So every time you push the code to GitHub, it will run this Jenkins file. Before we start integrating anything into our Jenkins, you will need to install some of the plugins. So you'll need to go to Manage Jenkins, Plugin Manager, and Available. And then from here, install the required plugins that are listed. So these plugins will let Jenkins connect to GitHub, run pipelines, and also work with Docker. So after installing them, make sure that you restart your Jenkins. Now for the last step is to test if your Jenkins is running smoothly. So after you've pushed your changes to the main repo, you'll need to go to Jenkins, select your app and click Build Now. Now you can use the pipeline console to check the results, and for future updates, every time you want to push your code, you should also build in Jenkins to make sure that your pipeline still works.
Hello, let's start with the setup for Docker, which is an important part for our CI and CD pipeline. First, we need to install Docker Desktop. Just go to the official Docker website, download the Windows version and run the installer with the default setting. After the installation, it's recommended to restart your PC to ensure the Docker runs smoothly in the background. After installing Docker, open the desktop, make sure it's fully running. You will know it's ready when you see the wheel icon in your system tray and the system says engine running. Next, we verify that Docker is installed and running by using the command Docker, using the dash version and Docker info. If the Docker is working correctly, you will see your Docker versions and the system details shown in the terminal like this. Next, to make Jenkins works better with Dockers, it's recommended to install a few Dockers related plugins. Just go to the Manage Jenkins and next to the go to Manage plugin, then install Docker pipeline and Docker commands. Once installed, don't forget to restart Jenkins. To let Jenkins run Docker's commands on Windows, we need to share our Docker with it. Just go to Docker desktop settings under resources, file sharing, and make sure your Jenkins workspace folder is listed. Restart Dockers if needed. Next, we test our Docker build locally. First, we create a simple Docker file in the project folder. Then run the command docker build -t while check -app to build the image. This ensure our application can be containerized properly before pushing it to the Docker Hub. Before committing any changes, make sure Docker engine is running. You can check the status in Docker Desktop or look for the wheels icon in your system tree. If it's not running, Jenkins will not be able to build the Docker image successfully. Now that Jenkins is running locally, we need a way for GitHub to communicate with it. To do that, we use standard channel to expose Jenkins to the internet using port 8080. This gives us a public URL that we will use in the GitHub webhook setup. Let the GitHub talk to the Jenkins. We text the public tunnel channel URL and add the GitHub webhook at the end. This full URL is what we will paste into the GitHub webhook setting as the payload URL. Now we add the webhook in the GitHub. Just go to your repository settings, click Git webhook, and paste the URL from the tunnel channel, ending with GitHub-webhook. Set the content type to the JSON, then click Add webhook to connect the GitHub to the Jenkins. Next, we test the webhook by pushing a commit to the GitHub. Jenkins should automatically receive the trigger and start the pipeline. In the GitHub, we can confirm this by going to the webhook, recent deliveries, and checking the response status, which is the failure or success. Now let's begin the Jira setup. First, we access Jira Cloud using our team workspace URL. In our case, we are using splash cafe atlassian.net. From here, we can manage our project tasks, issues, and integrate them with GitHub and Jenkins. Once we are in the Jira Cloud, we go to the Atlassian's marketplace by clicking on the apps, find new apps. Then we search for the GitHub for Jira and click Get Apps to install the official integration plugin by the Atlassians. After installing the GitHub for Jira app, we go to Apps and manage your apps. Then find GitHub for Jira in the list and click Configure. This tab links our GitHub account to Jira so it can start tracking repositories and commits. Now we switch to GitHub and go to Settings and Install Apps. Click Configure next to the Jira apps. Choose the GitHub account and repository to link, and then return to Jira to confirm the integration is successful. To integrate Jira with Jenkins, we install the Jira plugin. Go to the Manage Jenkins, Manage Plugin, then search for Jira. Install both the Community plugin and the optional Atlassian Cloud plugin for better compatibility, then restart the Jenkins. To allow Jenkins to communicate with Jira securely, we create an API token. Just go to your Atlassian's account, which is the Jira account, generate a new token and name it like Jenkins integration. Copy it immediately, then save it in Jenkins under managed credential. Next, we add the Jira API token to the Jenkins. Go to Manage Jenkins, Configure System, then click Add Credential. Here, we enter the Jira email as the username and paste the API token as the password to enable secure Jira access. Now we complete the integration by adding our Jira site in Jenkins. We enter the Jira Cloud URL, set the credential with our emails and API token. Then click the test connection to make sure everything links correctly. Okay, finally, we add this stage in our Jenkins file to automatically comment on the related Jira issues. After each successful build, Jenkins will post a message to the Jira tickets and helping the team to track the progress in the real time. In the final step, we see the full integration in action. After pushing code to the GitHub, Jenkins is auto-triggered via webhook. Then it posts a comment back to the Jira issues using the REST API, making the workflow fully traceable and automated.
Hi, I'm Nursafiza, and I'll be explaining on setting up Kubernetes and Minikube. First, we need to install Kubernetes and Minikube automatically by opening Terminal or PowerShell. After successful installing, start Minikube cluster by running this command to make sure Minikube use Docker engine. This will create a local Kubernetes cluster, and also make sure that the Docker file has been created and the engine keeps running. Then create a Kubernetes file named deployment.yaml and service.yaml in the project and replace the project name. Lastly, launch Minikube dashboard by running the command. This dashboard will use to monitor pods, deployments, service, namespace, and cluster info.
Now that you have configured everything, you will need to test the CI/CD and CT workflow after the integration. So the first step on CI/CD CT workflow is you will need to open Docker. Now make sure that Docker engine is running. The reason is because both Minikube and Jenkins rely heavily on Docker. This is because Minikube needs to run the containers and Jenkins use it to build and run the Docker images for your pipeline. For the second step, you will need to start your Jenkins locally by running the command in your terminal. So once it runs on the port of 8080, you can open your browser and go to the localhost 8080 to access the Jenkins dashboard. Now for step 3, we want to trigger the build automatically. So since Jenkins runs locally, we will use local threader to expose it to online so GitHub can send webhook events. So you need to run lt dash port 8080 in your terminal and then use that generated URL as your webhook in GitHub. So you need to remember that this link will always change if the tunnel closes. So it must be active in order for the webhook in GitHub to work. Now that you have made changes to your code, you want to commit your changes. So you need to push them to the main branch in your GitHub. So since we already set up the webhook earlier, this push will automatically trigger a Jenkins build. So if you also included a Jira issue key, like for example TW15, like your key Jira with the number in the comment message, it will also appear under the development tab in Jira. But this part you need to make sure that you link your Jira with GitHub. So once pushed, you can check the webhook's recent delivery and also the Jenkins dashboard to confirm if the build that you trigger just now is completed and successful or maybe either be failed. After your CI/CD process is success, you will need to start Kubernetes for the continuous testing. First, you will need to open up your project path in the terminal and run the Minikube start to launch the Kubernetes. Then, you will need to check the dashboard using the Minikube dashboard command, and it will open up your dashboard. So from here, you will need to make sure that 3 sections, deployment, pods, and replica sets are healthy. Next, you will need to run the command kubectl get pods and kubectl get services in your terminal to verify that your pods are running and the services are active. Finally, once both of those commands is a success, you will need to use Minikube service to open and access your deployed app in the browser. So for example, if your app crashes, it could be due to image errors or configuration errors. So using Kubernetes, it helps to detect the problems early by simulating a production-like environment. So once everything looks good that you can run, you can start to begin your testing your system directly from the browser that it opened up.
Next, in part B, we will focus on identifying and addressing code smell found in our project to improve code quality and maintainability. In the assigned patient controller, we found that each method redundantly called authenticate logic and fetch the login doctor manually. This violates the try principle, leading to code duplication, harder maintenance, and ecosystem testing. To fix this, we create a helper method called getLoginDoctor. Now every method in the assigned patient controller use this helper to retrieve the authenticate doctor. This makes controller code cleaner, reduce repeated logic, and ensure consistent user retrieval. It also improves maintainability and align with clean code practice.
Next, the code smell that we found is using anti-pattern injection. For example, in the mail function, it uses auto-wired, which is used to inject dependency directly into private fields. This shows an anti-pattern in the modern Spring development. This will prone to make dependency hidden and not visible in the constructor. fields cannot be declared final, and breaks immutability, harder to mark for unit testing. Thus, to counter this issue, we replace failed injection with constructor-based injection, so Spring will automatically inject dependency through the constructor. This makes dependency explicit, testable, and easier to manage. These changes will have clear and visible dependencies, field can be declared final for immutability, and enables easier marking in unit tests, follows Spring Boot best practice, and improve code readability and long-term maintainability. That is all from us. Thank you.